Hello. Today we're just going to look hypotenuse leg theorem. This theorem only can work in a right triangle. All right. Once again, hypotenuse leg theorem or postulate can work only if you have right triangle. What is right triangle? You have to have a 90-degree interior angle, 190-degree interior angle in a triangle. That's called right triangle. All right. Then if you have 90-degree in a triangle, opposite of that 90-degree angle, the opposite side called hypotenuse. The other two sides are called leg. So once again, opposite of 90 degrees called hypotenuse if you have a right triangle. All right. So now the hypotenuse leg theorem is if the hypotenuse and leg of a triangle, so if you have a hypotenuse and a leg of a triangle are congruent to the hypotenuse and leg of another right triangle, then the two triangles are congruent. So if you take two triangles, you have hypotenuse, leg, and make sure that those two triangles has 90 degrees, then these two triangles are congruent. All right. So let's look at this video and see how does it work. Okay.
Triangle congruence. What I'll do in this video is I'll show you an exception. And the exception is when we are dealing with right triangles. In particular, is a right angle. So this is a degree angle, in which case this first side is going to be the hypotenuse, and the second side is going to be a leg. And that's why you'll sometimes see this, instead of calling it SSA for the special case of a right triangle, you'll sometimes see this as hypotenuse leg congruence, which is in the same colors, so I'm consistent. So hypotenuse leg congruence. And if someone's saying there's a hypotenuse of that triangle, then that triangle by definition is going to be a right triangle. You can only have a hypotenuse in a right triangle. And to get an intuition for why two triangles are going to be congruent if each of their hypotenuses have the same length, is it hypotenuses, if they have the same length and then the leg has the same length, we can look at these two right over here. So we are going to assume that this hypotenuse has the same length as that hypotenuse. Let's say they're both of length C. We can assume that this leg here has the same length. This leg here has the same length as that leg. We could call that length A. And you can see that the only way to draw the next side, remember, there's two constraints now here. We have to connect to this point right over here as we're dealing with a triangle. So we're only going to have three sides. And it's a right triangle. So it has to be, the next side I draw has to be perpendicular. So the only way to draw that is just like that. And to feel good that, I guess more analytically, that this side, this green side is congruent to this side, we could just use the Pythagorean theorem. The Pythagorean theorem would tell us that this green side right over here is going to be the square root of the hypotenuse squared, c squared minus a squared, minus the square of the other leg. And this one is also going to be the square root of c squared. Actually, let me just draw an arrow. This is going to be true for that, and it's going to be true, and it's going to be true from that. That comes straight out of the Pythagorean theorem. So from that, we know that the third leg, or the third side, that those two corresponding sides have to be congruent. And so that's where we get the hypotenuse leg congruence from, which is really just a special case of SSA, which we said in the past, you cannot apply generally to establish triangle congruence.
So now you have
In this
the
video, we're going to
understanding.
focus on proving if.
Sorry. So now you understand, how that works. So I have two questions on the checkpoint. If you want, I can show you over here. And I will put in this video too. So there's a problem. We have two triangle over here. Actually, how can we call the big triangle? It's called isosceles triangle. Why? The big triangle has two sides are congruent. Now, that is not the point. In here, they gave you PR is perpendicular. This sign is called perpendicular to QS. So QS is this line segment and the PR is this line segment. So PR is perpendicular to QS. That's mean, what does perpendicular mean? It split that straight line into 90 degrees on both sides. Now you have to prove triangle QRP or PQR is congruent to PSR. All right. I already stated all the statement over here. I'm just going to make sure everything correct, and then I'll. This one should be. Hold on. PR is perpendicular to QS. Okay. And then triangle PQR is congruent to PSR. Now you have to fill out all the reason. In here at the end, we just learned hypotenuse leg. So that the reason it's going to be, so you look into it. And there's another question. You have A is 90 degrees and C is 90 degrees. All right. And then AB, which is AB, sorry, AD. AD is equal to BC. Now you have to prove triangle ABD, this triangle on the top, is congruent to DBC or DCB. ABD and DCB. All right. So these are the two questions. So please try to put all the reason and prove it. And if you have any help, every day this week, you can come to my office hours from 10 o'clock to 11 o'clock. Or if you want to make any appointment, please text me. My phone number is 401-408-3392. Thank you.